Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and Komodor. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting discussion ahead, but before we begin, I have just a few housekeeping notes. First, today's session is being recorded, so if you miss any of today's discussion, or you would just like to share it with a friend afterwards, the on-demand webinar will be available shortly after we conclude today. If you have any questions to submit throughout today's webinar, you can use the Q&A tab on the right side of your screen. We'll try to answer as many as we can, and we will also answer them towards the end. So be sure to send them in early so that we know to make enough time to answer all those. And also, you can find that chat tab on the right side of the screen. This is where we want you to engage with one another, add your comments to our conversation, or just let us know from where you're tuning in. Finally, at the conclusion of today's webinar, we will have a drawing for 4 $25 Amazon gift cards. So, on to our topic at hand. We'll be discussing 5 things we learned not to ignore while scaling Kubernetes, and I'm joined today by Guy Menahem, Solution Engineer at Komodor. Guy, it is my pleasure to turn the floor over to you at this point in time. Thank you so much for being here with us.
Thank you very much, Cody. So let me share my screen and start to introduce. So what we are going to talk about today is the 5 things we learned not to ignore. A few notes, as Cody said, you feel free to ask any questions. Thank everyone for posting questions and say hello. It's very nice and exciting to see you here. We are going to talk about the topic, 5 things we learned not to ignore while scaling Kubernetes. Let me first introduce myself. I am Guy Menahem. I'm Solution Architect at Komodor. Komodor is a startup that building the first Kubernetes native troubleshooting platform, which means me detecting issues in the clusters or in the services. We provide all the contacts for DevOps and developers to troubleshoot independently and easily and have all the information they need to figure out things with all our insight and suggestions. So I'm a developer turned into a solution architect, which means I love to develop. I love the Kubernetes. I love everything related to it. And I really love infrastructure in general. I think that infrastructure actually drives the world by applications. You need the application and the infrastructure to work well together and well-defined. So I love storage, networks, and all the dirty stuff that not all people like. One of my biggest motto is that I want to sleep well. I think everyone wants to sleep well. And if you want to sleep well, you need to plan well. If you plan your infrastructure to scale well, then you're going to have a very nice sleep. So if you join the webinar, it means that you're thinking about scaling. Maybe you want to learn how to prepare for the next scaling. And scaling Kubernetes is pretty tricky because if you are a small company, have not a lot of engineers in the company, and now you're going to the business start to grow and the applications start to grow and the teams start to grow, you need to be prepared of that. So a lot of organization going from a small startup to a big company, and the Kubernetes cluster are going to rise and add more applications, more services, more workloads, and the reliability should be much higher. So those kind of first scenario, people scaling Kubernetes cluster. The other one, which is super important, they are already well-defined, well-based businesses that are trying to move into Kubernetes. Let's say you have instances or working with VMs or on-prem, and you want to scale your Kubernetes cluster and do the migration of applications. And the migration can be tricky because it starts very small. You moved your first service, maybe your second service, and now you need to run your critical workloads. That means the infrastructure is going to scale, Kubernetes is going to scale. And if you feel familiar with all the things I said right now, there is a reason for that. So we see in a lot of research that a lot of organizations are going to scale their Kubernetes clusters in the next few years. So it's about 90% organization say that they are going to scale the cluster, which means a lot. It's not like 50% number that we can argue on. It's absolutely 90%. And we all know why. And if you don't know why, we have the numbers. So if you want to deploy application more faster, this is the things that people want to have to move into a SaaS-based platform, making more deployment. have the ability to take code from one place, run it on the other, from one cluster to the other, and make sure it runs well, and the easier updates. So it's all about delivery to make your business be critical. But as we know, it's not only about making the cluster scale, because it's not that easy. Scaling a cluster and scaling Kubernetes clusters can be very hard, and we see a lot of challenges around these areas. So for example, we see that infrastructure blind spot can cause a lot of pains or things that you don't take into consideration in the first place, as well as hidden costs, because if you have some hidden infrastructure that you are not aware of, you're definitely going to pay for something that you are not aware of. And as we know, cloud bills can be high. Unsuitable rollout and rollbacks can cause impact to your business while you're doing these deployments and can cause a lot of damage, as well as missing contacts that take you a lot of time to troubleshoot and understand things. And the knowledge and culture gaps that we see while people adopting more Kubernetes, they can make a huge difference between a good scaling or a good migration process to the ones that are taking a long time to accomplish. So we are not here to talk only about the bad and challenges. So we have a lot of information from a lot of customers that we really want to share with you and make sure that when you're planning to do your scaling or while you're on scaling, you maybe miss some of the things, you can learn from us and share this knowledge as well. So the first thing that I want to talk about is the infrastructure. So our Kubernetes cluster built by nodes, and some of the nodes are static and some of the nodes are dynamic. Let's say I own an e-commerce website that I run. So in most of the workdays, I don't have that much workload, not a lot of people going to buy things. So I want to make a static infrastructure that can suit my needs and workloads, but at the weekends that we have more buyers, more people want to buy things, we definitely want this kind of dynamic or support the peak capacity. And all of things need to be automated. And the cluster size actually changes during the time, changes going larger, going smaller. And we need to decide our ratio, how much cluster is static and how much the cluster is dynamic. Because if you're going with a very large dynamic, we're going to have some troubles. And if you're going a very large static configuration, we are going to pay much money and not use it very much. So in the day-to-day, we mostly want to use static, and the peak capacity, we want to use dynamic. And now we are going to deep dive about what are the considerations that you want to take into the static and dynamic, and what are the ratio may going to be decided by you. So the first thing about static infrastructure, which means that we need to find our application nodes and instances size that match actually to what their needs. There's no two applications that runs the same ones. Like they have slight difference. Some of them are bound by memory, some of them bound by CPU. And all these things that matters to the application going to impact your application size. So if you do sizing for your deployment pods, you need to take into consideration maybe RAM or CPU. But sometimes the problem is the request. You want to scale the number of replicas of your deployment or your code or your application by the number of events in the queue, or maybe the number of requests that you want to achieve. So there is no right formula to what is good sizing for application and bad. You need to find your own one. And finding takes some time and know your application. So if you are a company going into the migration, you may know that, but if you are a small company that's going to grow and you have this scaling issue, you definitely want to have and know that. And depends on the application size and your services size, you need to decide your node and instances size. So what can be count on node size? Because we want all the application actually runs on nodes. And we need the nodes capacity to match to our application needs. And what can affect or we need to take in consideration when we're picking the node size. So in cloud provider, we have this max number of nodes or pods that can run on one node. And we want to know how many pods that we want to run at the static and for cost and dynamics. So we need to calculate that in advance. We may going to run a few daemon sets. Daemon sets are going to be multiplied by the number of the nodes, which means a lot of them if we have a very small node and we have many nodes. But if we have like only 2 nodes, we are going to have like 2 replicas of the daemon set. We need to take into consideration the eviction hard limits, which means sometimes if our application going to consume a lot of resources, the node's going to be evacuate some of the pods, and this is going to impact our application. So we need to understand that what is the capacity of the node that we want to achieve. And for sure, we want to manage our overcommitment. Overcommitment, which means we're going to have request more memory that we got. And all that things matter what node size do we want to pick that can fit our application size. And in here, there is a balance. We need to understand what is the static and what we need at the day-to-day. And then we're going to add the dynamic and maybe use the static all the way. So make sure you pick your right application size and do your formula to what a good application size, and pick the right node and instance size for you that will be able to support your application and business needs. Things that you need to remember, which sometimes people forget and they can make a lot of trouble, is the networking requirement. Every pod and node is going to take IPs from your subnet. And if you, for example, pick a very small subnet on VPC, you're going to sometime going to reach your capacity. So think that as well. And for sure, you need to take in place the number of clusters. So the number of clusters can vary. If you have 2 of them, not many nodes, but if you've got 1,000 of them, you're going to run a lot of cluster, and that can multiply everything. So this is everything about static infrastructure, but what is dynamic infrastructure? Dynamic infrastructure is how we scale our applications. So we have 2 ways to scale our applications. One is the pod-based, caused by the HPA, is the horizontal pod autoscaler, which means at any time that we define metrics, and when the metrics exceeded the thresholds, the HPA going to add more pods and change the replica numbers. So by that, we can increase or scale our application size. But what's going to happen when the nodes are running out of pods or running out of resources? Then the cluster autoscaler going into place, or any other autoscaling methodology. And then when pods are pending or resource consumption of all the nodes is exceeding the threshold, then some kind of autoscaler are going to add more nodes to the cluster, which means that we are going to extend our cluster in the number of nodes. And it can be varied. There are some companies that working with, let's say, 10 nodes at the start, and the dynamic configuration can be up to 100 nodes for peak time, Christmas times, Black Friday, and things like that. And some people use very small autoscaling because they have like 2 nodes and we want to increase the capacity only to 4. So you need to understand what is your requirements and how to adjust it. Something that you need to take into consideration is that scaling can be very specific and can be very specific to our node groups, which means you're going to scale only specific node groups. And these things means that in some places you need that kind of scaling only to a specific node group. And this is about dynamic infrastructure and how it works. And you should plan what is good for you and what is the right size for you. What can help you to do that? I really like the Learn Kubernetes nodes or instances calculator. You can fill all the details in it, and it will help you to understand what is the right node for you, what's going to be the price of this node on various cloud providers, what is the utilization or efficiency of that pod. So you can use that tool to calculate your node size and then understand what you go with the static and what you go with the dynamic. So feel free to use and take the link and use it. It's a very nice tool. I really like it. So the second thing about our infrastructure is not only about, so we got the right sizing, and it's not only about sizing, it's about optimizing our cost. And you know that cloud bills can be very high and can be vary from small cost for a small startup, small organization, but when you grow, the cloud bill going to be high, and it's very hard to understand what you paid for. And optimizing the cloud cost can be really helpful to understand what you paid, how I optimize it, how I save money to the company, and how I do not pay more or not much more when I go with a larger dynamic infrastructure. So when we are running on cloud, we can pick to run on spot instances. Spot instances, which means they are ephemeral instances, and they can't taken by the cloud provider after a short amount of time. So the infrastructure going to be very dynamic, but what's nice about that, it's going to be cheap. So we pay much less money for that infrastructure. What is the problem with running on spot instances is that you can going to be ready to voodoo and phantom issues. So we heard a lot about customers that when they have spot instances, they have a lot of issues. They don't know what is the root cause of the issues. They sometimes suspect that the nodes cause them, and they don't know why. So a lot of companies are coming to us and say, okay, I want to investigate and understand this was an application issue or a node issue. It's very fragile and frequent, so it's hard to understand. And you need to understand that you need to manage and handle it. On-demand instances are the most common instances, which are the instances that are reserved for you. They are always there for you. They are very stable, and you can trust them, and they are reliable. The problem with that is they are expensive, so they cost much more than spot instances. So you need to pick what is good for you. There is a method that you can run with mixed. For example, you can choose the ratio. I want to run 60% with on-demand, so it's going to cost me that much. And the other instances in the cluster are going to be spot instances, which means all the dynamic infrastructure going to be very, very cheap for me. What I really like about that is that mixed infrastructure is very flexible. You can always change your ratio. You can always go from one platform to the other or change the instances from one another. But what problem is that I prefer not go with non-uniform infrastructure. Why is that? Because when you have trouble, you need to figure out not only if it was a node issue, but you need to figure out what node issue it was. So uniform your infrastructure can be very beneficial. And so you're not going to get that much voodoo and phantom issues as you got for full spot instances, but you're going to get slight of them. But in each one of them, you're going to investigate hard. So pick what you want, make sure you know to optimize the cost, and make sure that you know what do you want to run with. So there's no one formula to use here. You need to pick what is good for you. And as you know, cloud cost or the cost of the infrastructure on the Kubernetes cluster is not only about cost. They can be software vendors and other vendors that we're paying them money. And all these vendors or third-party tools can cost you very, very much. And what you need to understand that in most of the cases, when your business grows and your infrastructure grows, also the vendor is going to cost more money. So you have your budget, and let's say you scale, and you predefined, as you said, you actually have all the metrics, what is going to cost, what is the max, how we predict that it cost going to be. And then when the cluster scales, you're going to pay a lot of money for the vendors. And if you're going to consume more than you agreed with them, then you're going to pay much more. And vendors like this kind of money because it's the easiest money for them. And as much as the Kubernetes cluster grows, so more nodes are going into the cluster. And if you pay by nodes, that's going to cost you more money. As much as logs or any other vendor cost by consumption. So what is good about that is that you pay only on what you use based on the SaaS and platform that you're using. And using that kind of consumption-based method is very nice. But when you exceed what you intended to pay, it's going to cost much. And then you're going to find yourself run into your management and say, okay, it costs more than we expected. We need to get more budget. But the business grows as well. So it's very fun and nice to know that the infrastructure grows with the application and business needs. So this about cost and optimizing cost and understand how we can save money and making sure that we don't have blind spot in our cost that can impact us and consume us time and money after. The third key factor that I want to talk about is the rollout and rollback. So rollout is actually how we do rolling our application into any cluster, for example, the production. So the simple way Kubernetes do the rollout is just replacing the node by some strategy, very basic strategy, and it's very nice. So when you are at 10 teams working together, 10 people team working together, everyone have the same access, knows to predict the rollout. The application is very stable and all the customer getting what they need and all the requests get satisfied. And let's say you have, like, for example, as an e-commerce site, you have these 6 customers per day that need to do the checkout, which is the most critical path. But at the end, when the business grows, maybe you go from 6 to 1,000 a day because the business grows. And now this is the business needs that we need to fulfill. And in that case, going into a very rollout that can cause disrupt or can be painful for application customers is something that we don't want to do. So what we want to do is at some point we need to get into more and better strategy. Let's say I don't want to use the Kubernetes one. I want to use much sophisticated, like canary deployment. I want to make sure everything is staged as well. I want to make sure someone is checking what's going on with the application and not scaling it just when the pod is ready. Maybe we want to do a A/B testing or blue-green deployment and every kind of sophisticated deployment to support our business and our application reliability. And if you want to do that, it's something that you are going to tackle. It's something that you're going to talk about. And there is the project Argo Rollouts, which I like. It's very useful. It's have all the ability to do nice rollouts. It's a deployment like rollout, and you configure it very well. And it's have huge capabilities in terms of rollout. And you can pick the rollout plan for what you want and what you need. So you need to think always that eventually some of the deployment and some of the rollout that's going to happen on daily basis, on even maybe on an hourly basis, going to increase, and maybe the rollout and the CI/CD are not working well in that case. So we define a good rollout. We know the strategy. We know how to support our business. We know that customer will not get any downtime, but any case, and all the requests going to be satisfied even when we are scaling. And now we need to think about the rollback. Rollback is when we run application with some defect and we want to roll back to the previous version. So rollback is things that you need to plan well. And rollback can cost a lot of damage to the system. And sometimes rollback even is not possible. Depends on how you plan your system and how you plan your rollout. So the first thing you need to understand that you're going to need the rollback, and rollback can impact you. And the second thing is to understand how do you do rollback. So for example, if I change only code in the last deployment I did, or the last deploy, so I can roll it back, everything changed back to what it was, and now my application run good and as I expected. But sometimes we need to add breaking change to application. For example, we change an API, we change something in the database, we change some scheme everywhere. So all of that you can really roll back, or you need to plan your rollback. So rolling back is the kind, during a breaking change is something that you need to prepare of. And you need maybe to test differently from everything else. And you don't want to get into that case when someone deployed a new code into production and you figure out something is wrong there and you need to roll back. You don't have time to push a new version to the production or fix this bug because you need more time to investigate. And then you understand that you can roll back. It's a very miserable place to be at because you can roll back. You know that you have this problem in production, and now you need to do something. Maybe a quick fix, maybe some push very fast, some workaround, but it's very miserable and place that you don't want to be. So plan it well, understand what is the rollout that you want to be, what are the rollback plans, and then you will be able to figure out how we support the deployment and the rollout and rollbacks based on our business and application needs. And it can vary. There are many of them. Some of them will go with the Kubernetes basic, and some of them will go with pretty advanced. And we saw a lot of them. We even saw some people that not using the Kubernetes and the Algo rollout to actually develop by themselves this kind of rollout because they want very, very, very specific thing. So if you're not in that extreme case, which I guess most of the people aren't, so use the simple one or use the Algo rollout one, but always think about the rollback. Always think about the rollback. So rollout and rollbacks are fine, but something that goes when you get into a larger environment is that kind of context. So when you have like 3 services, maybe one of them is not a monolith, but very large one to do all the heavy lifting. So you got these services, you know all of them, maybe by memory, maybe you know the owner, maybe you know everyone that's going into that. And it can be even in a 50 R&D team, 50 people R&D team. But when you're going into larger environment, it doesn't scale. You need to provide more context. When you get into an issue, into a service, you need to understand maybe who owns it. What is the version of the thing? Not by only image version, maybe other version, like maybe I want to add my internal change management system into it, and I want to provide more context to that. So we understand that when people troubleshoot context or investigate issues, this kind of context that is very achievable and easy to understand can save a lot of time. So if you want to add metadata and context to your services, you can use labels and annotations. So basically, labels and annotation are key value pairs most of the times that can help you to label, which means Kubernetes is going to use this label to do things, and annotation, which are key value strings that you can use to add more data. So labels are Kubernetes things that Kubernetes use to, for example, know which pod you need to manage. You can use kubectl with the flags to filter by label, which is nice, or select pods for the HPA metric collection. And annotation, there are things that Kubernetes does not manage. It is aware of it, but is not going to use it. And if you are going to use annotation, you need to understand what's going on well. And for example, we see a lot of people going into investigation and what they're asking themselves, who owns that service? Who is the owner of that? And as we're moving into the cloud or the Kubernetes or the more DevOps attitude that I'm going to talk next at the next slide, we need people that owners. We need to get the context. We need to understand that there are many systems involved in the change in that service. And we want to provide that context. So my suggestion is that when you prepare Scale, make sure that all the services and all your applications tagged, labeled, annotated with all the context that is needed for them. It can save you a long time. It can going to make the owners of the service understand what he is looking for, where his name at, and how it can be reached, and use that to understand much better what you see when you're troubleshooting. So this is about context, and providing context is a good thing to do anytime, anywhere. The final thing that I want to talk about is organization and culture. So organization and culture are key factors when adopting and migrating to Kubernetes. So when we are migrating into Kubernetes, there's not kind of one-off that people in the company going into one project and you finish the project and then you move on. No, Kubernetes is something is very iterated in your culture, iterated in the way you deploy things, iterated in everything you do. And it's integrated in the development and deployment process that you are going to have. And if you are a DevOps, you need the devs or developers in the company to be very attract and know what is Kubernetes. So you want to have this kind of DevOps developers, SREs relationship that make sure everyone buy into that project and invest time to understand that we are adopting Kubernetes. We are going to benefit much of all these powerful things, all this reliability, all this self-healing, all this configuration, easy configuration by YAMLs and by declaration and not imperative configuration. And operators will not do manual things about that. So we need to get buy-in from the devs team if you are a DevOps, but if you are a dev, you need to get buy-in from everyone. So make sure you got the buy-in from everyone, because we see a lot of people that the DevOps in the organization try to adopt Kubernetes, moving some services, and the developers or the SRE in the organization actually don't know how to handle it. They used to run on VMs. They used to work in a previous companies, and now they join the company and they don't know Kubernetes at all. But what we expect for them as a DevOps is sometimes to troubleshoot by themselves. Understand the kubectl command, understand how Kubernetes works. We prefer to not get Slack or emails or any messages about, can you help me to figure this out? And then you understand the issue is just so simple one. So prepare and spend time to get everyone to understand what is Kubernetes, how to use it, what is the best way to use it, and give them tools to use it. The tools that most of the time you use before working with Kubernetes are going in that one attitude. But when you're moving into a mode cloud native approach, sometimes you need to adjust the tools. So the tools previously used now need to be adjusted. So for example, let's say that you are using some metric, and we have this kind of tools that you send your metrics to, and you have many dashboards in it, like full of dashboards. The developer can see everything about the application, but they don't know how to work with that kind of dashboards. So as DevOps are people that are more aware to what is Kubernetes or what is this platform and how we can use, we need to adjust, takes one small bite at a time, make sure they are onboarded. And finally, after people gain traction with the platform, get interaction with the tool, we adjust the tool to make them easy to grow up and scale and learn and actually understand what is the platform and how to use it. By learning the tool and understanding the tool, it can be a huge impact in the adoption in your company or your organization. And we see that in some places, people actually do not grant access and maybe do not bring the tools to developers to understand that. So for example, there are organizations which developers have kubectl access because they want to be empowered and they want to work extremely close to their cluster in the QA, in the staging and things like that. And we see cases that developers don't have kubectl, they don't know what pods are, deployments are, but actually someone expects them to understand that and understand how Kubernetes works and how the application works in their production. So grant them the access to understand and figure out things by themselves and let them the time. And if you learned previously, now they can understand much better how to use and what in front of them. And the last thing is about communication and how to make things better. So we know that iterations together with all the people involved can make the difference between a successful migration and an unsuccessful migration that takes a lot of time. So we want to make sure that we implement the best practices, but we also communicate and iterate over that to get well known what is the problem, what is the issues, how we can overcome that together. We see a lot of places that the developers are really not communicate with the DevOps, which can be a good thing if they know how to use the platform, but sometimes they are expectation from one another that are not achievable. And we really want to understand that you are into it and you know how to iterate and you get involved in that. So this is the last thing about organizational culture. And you need to adapt the new things, and everything will be better and nice if you adopt Kubernetes or if you migrate from your own premise to this one. And that's it. This is the 5 key things that we learned about scaling our clusters and from our customers' clusters. And now we have some time to Q&A. So,
All right, so I'm scrolling through some questions, Guy, and let's see what we've got. So this first question reads, how detailed should my labels and annotations be?
Yeah, wow. You should have this kind of, you should find your way to understand what are good labels that help you to understand and give you all the context and annotations. So you will be able to provide a good context for yourself. So this is something you built, and this is something you are going to use. So there is no line between what is good and what is bad. So if you have none, I think you're in pretty bad place. But if you have a bunch of them and you can read them, so you're pretty bad place also. So you need to find your balance. If you are in the right place and you feel you have the right context when you got into a service, so I think this is the sweet spot for you. And adjust yourself and iterate to get into that place.
Awesome. So our next question reads, are there any tools that you recommend that make it easier for developers to troubleshoot issues on their own?
Yeah. Actually, I have some. I think that one of them is Learn Kubernetes. They have a bunch of tools, as I showed you previously. This one with adjusting sizing, but they have a lot of tools and a lot of information. I really recommend this website because I like it. The other thing, actually, in Komodor, we released recently a tool called ValidCube that helps you do everything relates to the YAML, like validate your YAMLs, secure your YAMLs, and actually make sure you don't have any problems in the YAMLs, clean them, like to clean all the unneeded information. So it's a good tool to use. I really like it. And something that is not about troubleshooting, but it's more about learning, because they are the way that you need to learn, and then you go to troubleshoot. There is a website called Katakuda, which I like. You can provision environment, and they have very detailed guide of what to do. And I found some very useful things that you can troubleshoot in their website and learn better. So I think those are 3 very useful tools for you.
I think this question might have kind of coincide with what you just added, but are there any free tools you would suggest to provide for developers as part of their Kubernetes learning curve?
Yeah, so actually those are the free tools to learn by the website, to learn by the Katakuda, which is a completely different website, and have a tool that helps you to handle the YAMLs, which is mostly the hardest part for people to understand and use.
Awesome. So that seems to be all the questions we have right now. I'm going to go ahead and give out our Amazon gift cards just to give our attendees another minute or so to submit any questions. So our 4 winners of the $25 Amazon gift card drawing are Nick R, Cyril M, Kaylin J, and Lynn Z. Congratulations to the 4 of you. Keep an eye on your inbox to claim your gift card, and if you don't receive an email, just check your spam folder. So looking back, I'm not seeing any additional questions. So Guy, I'll go ahead and give you the floor one last time if there's anything you want to say before we close out.
First of all, I want to say thank you, Cody, and thank for all the audience for joining us today. I enjoyed to be here, and if you have any further questions, feel free to email or going into our website and post a question for us, and I would love to answer and be in contact with you.
Awesome. Thank you so much, Guy. So real quick, a reminder to our audience that the session was recorded. So if you missed any of the session or you would like to share it with a friend, the on-demand recording will be made available shortly after we conclude the webinar. You can find it living on the DevOps website. And if you signed up for this event, you should be getting that recording via your email shortly. So quickly, I'd like to thank Komodor for sponsoring today's webinar. And my final thanks goes to you, our audience. I really appreciate you being here with us today. Please take a moment to fill out our post-webinar survey, and we hope to see you at a future TechStrong Learning webinar. This is Cody J. Brown signing off.